Hello there, welcome to APES Chapter 20 lecture video part 3. We're now going to talk about the other alternative to fossil fuels. The primary alternative is hydroelectric power. This is one of the main ways we produce renewable energy in the United States. Hydroelectric power means using the movement of water. What's a fancy word for movement? Kinetic energy, the energy of motion. So as water moves, as long as you can get it to spin a turbine, so water moves, spins a turbine, you're going to have a generator in there that is going to have magnets and copper wire, and the magnets move around the copper wire, and as they move around the copper wire, it will generate electricity. So basically what you have learned in most of our lectures is electricity, we generate it mainly here on Earth in the form of getting things, and copper specifically, to move around, magnets to move around copper. So we need to get things moving. When we set things on fire, we create steam that helps move the turbines, the rotors of the turbine. When we use a hydroelectric plant, we use the flow of water to spin the turbine, and motion will then create kinetic energy, will then be eventually turned into mechanical and then electrical. Most hydropower plants use what's called the storage technique. That means they got a bunch of water sitting behind a reservoir, and when they open the floodgates, water gets released through. So this is called the storage technique, like a typical dam storing water behind it. There's much more water behind it. It's more uphill. They store it and they release it through. Okay, that's how it works. The run-of-river technique. Well, why is this technique used? Well, first off, let's talk. It's generally used in more remote areas, areas where you can't really necessarily build a large dam. You're not trying to fuel electricity for a giant area. Maybe it's a farm, for example, or a large plot of land that someone may own. You're probably not attached to a typical electric grid. So this is your means of producing electricity for your remote location. Well, what do? It's called the run-of-river technique. So a river runs through it. It doesn't need to be a very large river. It could be a small river or a tributary to a river. It runs through. What happens? Well, you have a pipe. That pipe picks up water, and the water runs through a pipe. As it gets through a pipe, on the other end, it reattaches and gets released into the river again. Before it gets released in the river, it runs through a turbine and through a generator and all that stuff, just like before. So it runs through the turbine, spins the turbine, which then spins magnets around copper wire, generating electricity for example, a farm or a remote area. So this run-of-river technique is generally used, like I said, in more rural areas, areas off the grid, kind of out of the way. Pump storage, what does this mean? Well, sometimes electricity gets very cheap. And when electricity gets very cheap, meaning there is a lower demand for electricity, there's no need to keep producing it. So they kind of want to pump it. So they use that cheap cost of electricity to actually expend energy and pump water and have it stored in a reservoir at a higher elevation. When you store the water in that higher elevation, when the cost goes back up, then you can release that water and convert it back into electricity. So it's a means of saving water in a higher reservoir, because electricity at that particular moment is cheap. The more you make, the cheaper it's going to get. So you need to kind of bring the supply down. So as the supply comes back down, the cost will go back up, and then you can release the water. And that's generally what happens in a pump storage technique. Hydropower, well, it's very clean. And it's renewable because it's going to rain, it's going to snow again. The problem is it's overused. We've dammed just about every large river on the planet. It's overused to the point where we've kind of hit a max with our hydropower generation. The major advantages of it, though, it's very renewable. Water is going to fall, water is going to flow downhill. That's just kind of how things work. So we're going to have the movement of water taking place. Is it efficient? Very efficient. An 80 to 1 EROI. It is the highest. All right, it's one of the highest out there. It is amazing energy return on investment. But we only have so many dams, and when you dam, so many rivers, and when you dam all those rivers, you're changing habitat in a lot of places. So it's not so simple. We can't just keep doing it. We're affecting other things. The big one though, there is no emissions from hydropower. So you're not damaging the air. Basically, you're not changing climate as a result of hydropower. The negative impacts, I've already slowly, briefly talked about them. Well, you shift habitat to the point where riparian zones, the banks of rivers, can get flooded at times, and in some areas they're not getting enough water. So it really changes the habitat a lot. Major habitat, specifically riparian habitat destroyer. When you suppress floods, you mess with nutrient-rich sediments getting to where they need to. So you're going to have soils that aren't nutrient-rich like they used to because you're suppressing flooding patterns. Flooding patterns naturally bring sediments to areas, and those sediments bring in nutrients. So riparian areas are generally areas that are flood preventers. They get flooded, and they're generally areas that have very fertile soil as a result of that flooding. But when you prevent or suppress flooding due to your river, you're changing the habitat big time, especially the soil fertility. When you have a dam, you're talking about heat pollution. All right. Why? Because it's generally shallower in certain areas. And when it's shallower, it's going to get warmer. Thermal pollution isn't bad because as the water gets warmer, there's less oxygen in the water. So thermal pollution leads to deprivation of oxygen. Thermal shock can occur if you all of a sudden release all this colder water downstream. You just shift temperatures rapidly and you change habitat. Also, fish have natural areas they want to move to for spawning, for example. So the movement or the passage of fish is deprived when you're generally damming an area. The thing about hydropower, we can't really expand it much, only because we've already dammed pretty much all of the large rivers on the planet. And that's the end.